We're going to look at algorithms in chapter 4.2. Algorithms, right, are just the systematic step-by-step procedure used to find an answer, usually to a computational problem, right? And we have algorithms we use to solve our addition, multiply, divide, subtraction problems. And so looking at, you get introduced here by 3 different methods by 3 different students to obtain the same answer. So it'd be good to kind of look at those processes before we move on, right? And so we're going to look at an algorithm, right, to what we use for addition. One is called the intermediate algorithm. The other one is the intermediate algorithm, but again with less steps, and the standard algorithm. This becomes important. The standard algorithm is what we learn in elementary school, right? And so you can see the different processes here going on. And so looking at these 2 intermediate algorithms, more steps are being written, but you can see that there's an understanding of place value. I prefer intermediate algorithm 1 because it shows a little bit more work. Here it's not writing the zeros, which is okay, but it's just an intermediate step, another one. And so looking at this, 8 plus 4 is 12, 60 plus 90 is 150. Noticing that this is you got rid of the 8 and 12, but you're still left with 60 and 90. And then you do 500 plus 300, and then you end up with your 962 there. And so that's what the intermediate algorithm is. Here it's the same, just without writing the zeros. You just keep over your place values, right? And then just add down. I like this one here because it shows me the values. Here is the standard algorithm. 8 plus 4 is 12. You keep the 2 and carry the 1. And again, most students don't know what they're doing when they carry the 1. They just memorize the steps. And we'll look at that, what's going on here. And then you do 1 plus 6 is 7, plus 9 is 16. Keep the 6, carry the 1. And then you end up with 1, 5, 3, 9. How about 34 plus 27 using multiple methods? So I'm going to do the algorithm, intermediate algorithm, the first one. 4 plus 7 is 11, and then you're doing, so what's really going on in my head is 4 plus 7 and 30 plus 20. And so you end up with 50, so your answer is 61. The other way is the standard algorithm. You do 4 plus 7 is 1, carry the 1, and then there's your 61. Less steps. This is more efficient. And so the standard algorithm is preferred, but early on students should understand that we're really just doing this process, and you may even want them to use that method there. And what's really going on with problems like this here, right? There's your 30. If you look at base blocks, there's your 34. And then you're adding, you're going to add plus 27. So when you combine these 2 together, right, you end up with 11. But what you do is you end up regrouping 11, right? You end up taking that set there and making another group of 10. And that's what that 1 is. Oh, I just added another group of 10. And so now you have 6, and then you're left with that 1. That's what's really going on with the standard algorithm there. There's some another way to add. It's called the lattice method. And so here's the example. Take a look. We're going to use, I'll do 2 examples for you here. What you do is you put your sum together and then make this configuration, what's called a lattice. That's what this is called. That's a lattice there. 4 plus 7 is 11. 3 plus 2 is 5. So 0, 5. Keep your digits. And then you add diagonally across. Notice what's going on. You add in this method process here. So 2, 6, 9. 1, 6. There's your answer. Here's another one. 9 plus 3 is 12. 2 plus 4 is 6. 1 plus 0 is 1, and then you add diagonally. So I get 2, 7, 1. There's my answer. Some people prefer the lattice method. That's it for subtraction.